Hello viewers, welcome to K Diagnostics. Dio here. Today we have a 2006 GMC Savanna with a 6.0 liter. The customer complaint on this vehicle is the check engine light remains on while the engine is running. So the first thing we're going to do is we're going to go inside the vehicle and confirm the customer's complaint. After confirming the customer's complaint, we're going to connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. So now let's go inside the vehicle and confirm the customer's complaint. Alright guys, so now we're gonna confirm the customer's complaint. I'm gonna start the engine. Let's see if the check engine light is gonna remain on while the engine is running. So right there, the check engine light remained on. So as you can hear, the engine is running, and right there, the check engine light remained on. So customer's complaint confirmed. The check engine light is definitely remaining on. So now I'm gonna turn off the engine. So I'm gonna turn the key to the on position. I'll bring up the scan tool here so we can scan the engine control module for some trouble codes. Alright guys, so here is the trouble code that we have in the engine computer. The trouble code that we have in memory is P0300 engine misfire detected. So this code is what's causing the check engine light to remain on while the engine is running. This trouble code can be caused by a couple things. One of them would be low fuel pressure. If there's low fuel pressure, this trouble code can be set. A vacuum leak around the intake manifold can also cause this trouble code to be set. I've also seen a defective O2 sensor cause this trouble code to be set. So the list is pretty long of things that can cause this trouble code to be set. So right now what we need to do is we have to pinpoint what's causing this trouble code to be set in the engine's computer. So my next step is going to be looking at freeze frame data. So let's click on freeze frame. So freeze frame is a snapshot that the computer takes of all the data PIDs when the trouble code is set. Okay, so let's click on this icon here. So the first thing I'm interested in is engine speed. So as you can see, our engine speed is 569 RPMs. So this trouble code set at idle, and our engine temperature is 206.60 degrees Fahrenheit. So the engine was hot. The throttle angle is 1%. Okay. Well, I mean 0%, I'm sorry. And then let's look at our long-term and short-term fuel trim numbers. So right over here, the short-term on bank 1 was 1% when this trouble code set, and the long term was 9%. On bank 2, the short term was 0% and the long term was 9%. So our fuel trim numbers were within a normal range. The normal range on most vehicles is plus or minus 10%. And as you can see, the total trim is within that plus or minus 10% range. Okay, so our fuel trim numbers were not high. So let's keep scrolling and see if there's any other important data PIDs here. So that's all. So our fuel trim numbers were fine when this trouble code set, so that's good to know. I'm looking at fuel trim numbers because the fuel trim numbers can tell me about the nature of the misfire. When you have high positive fuel trim numbers, it means the engine is starving from fuel. Okay, you can have a misfire that's been caused by fuel starvation. Earlier I talked about low fuel pressure. So if you have a fuel pump that's going out, your fuel trim numbers will be positive. You have high positive numbers. And usually when you have an ignition misfire, let's say a bad coil, you will have high negative numbers, okay, because all the fuel that's going to be injected in the cylinders is not going to burn. because the spark is not occurring. So you have a lot of raw fuel being pushed into the exhaust stream. Okay, so the O2 sensor is going to pick that as a rich signal, and the computer will actually be taking fuel away. So if you see high negative numbers, it means you have a misfire that's being caused, that's most likely being caused by the ignition system. Okay, lack of spark. So either a bad spark plug or a bad spark plug wire or a bad coil. So it looks like the fuel trim numbers here are not too bad. So this is a very minor miss. It's not a dead miss. If it were a dead miss, the fuel trim numbers over here would be either high positive or high negative. Okay, so now the next step I'm gonna make is looking at live data. Okay, so let's go to live data. We're gonna click on live data. So I want to look at the data and see if there's one specific cylinder that's misfiring. Okay, so let's see if we have some misfire counters on this. So over here, misfire. So we're gonna look at some misfire data. So the P0300 trouble code doesn't tell us about one specific cylinder. The P0300 code is a random multiple cylinder misfire. So we don't have a direction, or we're not getting pointed towards one specific cylinder. So these misfire counters will help us identify what cylinder is misfiring. So right now, of course, the engine is off, so we don't have any cylinder counting. Let's scroll down and see if in the history there will be one cylinder with a lot of misfire counts. So right over here, so cylinder 3 and cylinder 4 are the ones with a lot of counts. So cylinder 3 has 1749 counts, and then cylinder 4 has 4279 counts. Okay, and then 1 has 16, 2 has 3. So it looks like cylinder 3 and cylinder 4 are the ones that are misfiring. Okay, so that's good to know. I'm going to go back inside the vehicle and start the engine. We're gonna observe these cylinders with the engine running. We're gonna see which cylinders will start counting as the engine is running. So we already have an idea of which cylinders that are misfiring, because 3 and 4 have the highest counts. So these two are definitely misfiring. So these two cylinders are the ones that are causing this P0300 to be set. But I believe the cylinder that's really misfiring is cylinder 4, because this one has way more count than the other one. Now, I haven't looked at the firing order of this engine yet. If this cylinder is next to this one on the firing order, since this is misfiring, cylinder number 4, since number 4 is misfiring, it can also affect the cylinder after it. So if cylinder number 3 is after cylinder 4 in the firing order, I would not be surprised to see misfire counts on this cylinder, because this one misfires, the crankshaft slows down, and the crankshaft is now going to pick back up on speed on the next firing event. So the misfire on this cylinder is also going to affect the cylinder after it. Okay, so I'm going to go inside the vehicle and start the engine, and then we will see, just to confirm, that cylinder number 4 and 3 are misfiring. Now I'm going to start the engine. Hopefully that annoying buzzer is going to go off while the engine is running. So right there, the buzzer went off. So let's bring up our scan tool. Let's go back to misfire data. I don't really feel a miss. It should be a really slight miss. So as you can see, the engine is not misfiring right now. So the engine is fairly cold, let's see the temperature. So the engine temperature is 136 degrees Fahrenheit. So this started misfiring around 200 degrees Fahrenheit. So we're gonna let it idle here for a little longer until it reaches operating temperature, and then we will look at it again. So I'm gonna let it idle, and then we will analyze the data when the engine reaches operating temperature. Actually, let's back out of here. I want to look at our fuel trim numbers also while the engine is running. So let's go to engine data 1. So let's scroll. So mass airflow sensor. Let's look at this data pid. O2 sensor. I want to look at the O2 sensor data page too. Okay, short term and long term fuel trim numbers. That's what I want to look at. Alright, so that's all. Show selected. So right here. So check out our fuel trim numbers. Our fuel trim numbers are really within the normal range. Okay, bank 1. So the short term on bank 1 is going between -2 and -1. The long term on bank 1 is 8, and the long term on bank 2 is also 8. So they are basically mirroring each other. Okay, look at the short term on bank 2. So it's going between 0 and -2 or -1, and this is definitely within the normal range. This is pretty good. We don't have a fuel starvation issue. We don't have a vacuum leak. If we had a vacuum leak, these fuel trim numbers wouldn't look this way. We don't have a bad mass airflow sensor or a dirty mass airflow sensor. If we had a dirty mass airflow sensor, these numbers would not have looked this way. Okay, bad mass airflow sensor symptoms are usually you'll have fuel trim numbers that are bad at idle, and then those fuel trim numbers will get better as you accelerate. Okay, as you increase the engine RPMs, then the fuel trim numbers tend to get better. If that's the case, then your issue is most likely the mass airflow sensor. So that's not the issue here. Let's back out of here. I want to look at our misfire data again. Let's see if number 4 is misfiring, and then we're going to go after that cylinder. Okay, right there, guys. What's the engine temperature now? So the engine is getting hot now. Okay, we are approaching operating temperature. So 190 degrees Fahrenheit. So on our live count, so cylinder number 4 is counting. So right there. Okay, so 4 and 3 are counting. So cylinder number 4 is definitely misfiring. So we're gonna focus on this cylinder. Okay. This cylinder is only misfiring at idle, but when I increase the engine RPMs, watch these numbers, they're gonna stop counting. You see? So it went up to 14 and then went down to 0. As I'm increasing the engine RPMs, it stops misfiring. Well, it misfires just a little bit, but it doesn't misfire continuously. So when I let off, it's gonna start counting. Okay? So this is happening at idle. I mean, although we saw that on our freeze frame data, but it's always good to double check, because you can't always trust the data the scan tool is giving you. It's always good to double check. All right, so now the next step is going to be finding where cylinder number 4 lives. We have to know where cylinder number 4 lives, and then we're gonna go after that cylinder. We're gonna go to that cylinder and check it. So now what we're gonna do is we're gonna back out of here. So let's go to Firefox. Let's go to the service information and look at the cylinder layout on this vehicle. Alright, so here is our cylinder layout. So bank 1 is on the driver's side, so this over here is the front of the vehicle. So bank 1 is over here. So this is cylinder 1, cylinder 2, cylinder 3, and then cylinder 4. So 4 is the second cylinder on the passenger side. Okay, so from the front going towards the back. Okay, so cylinder number 4 is this one. So this is good to know. So now let's look at the firing order. So here's the firing order. And remember, like I said, if cylinder 4 is misfiring, if cylinder 3 is after it, it's also going to affect that cylinder. And right there, like I said, cylinder 3 is after cylinder 4. So 4 is misfiring and 4 is affecting cylinder 3. Okay, so let's focus on cylinder 4 first. Okay, and I'm sure when we fix whatever that's causing this misfire on this cylinder, this one over here will stop misfiring. Okay, so at this point the next step is going to be going under the hood. Okay, so since our fuel trim numbers are good, they are within a normal operating range, we are not starving from fuel, so this engine is receiving the correct amount of fuel. Now what I want to do is I want to look at this spark plug and the spark plug wire, because it feels like it's a very minor miss. It's just missing just a little bit. It's not a dead miss. So I believe this car is gonna need spark plugs and spark plug wires. So what we're gonna do now is we're gonna go under the hood. We're gonna locate cylinder number 4. We're gonna see where cylinder number 4 is. We're gonna use a lab scope. This ignition system has ignition coils and spark plug wires and spark plug in each cylinder, and this engine has individual coils on each cylinder. This is gonna be a good opportunity to use my new tool that I just got recently. So we're gonna use this VCMI. We're gonna use the scope on this VCMI to test the secondary ignition waveform to see if we have a bad wire or a bad coil or maybe just a bad spark plug on this vehicle. Okay, so let's go under the hood. I'm gonna turn off the engine. So now let's go under the hood. We're gonna get this scope hooked up and then we will see what we find. So now let's go under the hood. Alright guys, so we are here under the hood. I put the VCMI over here on the windshield so we can connect our test leads to it. The cylinder number 4 is over here on the passenger side. So cylinder number 4 is going to be the second cylinder on the passenger side, and this bank over here is bank 1. So we're going to have to move this surge tank out of the way. I want to show you the ignition coil. So I hope you can see in there. Let me zoom you guys in. So right there, this vehicle over here has a coil and a wire and a spark plug on the cylinder head. So what we're gonna do is we're gonna use our secondary ignition probes for the lab scope. We're gonna clamp them around this wire over here, the spark plug wire, and then the other side of the test lead is gonna go to our VCMI over here on the lab scope. I'm gonna use 2 channels. We're gonna put, so this is our secondary pickup test lead. Okay, so I'm gonna use 2 channels on the scope. One channel is gonna be connected to cylinder number 4 that's misfiring, and then the other one I'm just gonna pick a random cylinder. Okay, so in this case I'm gonna pick cylinder number 1 because this one over here is easy to get to. I'm gonna clamp around this. We will compare the ignition pattern of this cylinder with the one on cylinder number 4. Okay, so basically what I'm gonna do, I'm gonna show you how I'm gonna hook this up on this side because this is easy to see and there's room here, and then I will do the other one off camera. So this clamp over here is gonna go around the spark plug wire. I clamped this around the spark plug wire, and then the ground, I'm grounding it over there on the block. Ideally, you want to ground it on the battery, but this won't reach back there to the battery. The other one will be able to get to the battery, but not this one. So now this end of the test lead is gonna go to my lab scope. Okay. So I'm gonna connect this to the lab scope. So I'm gonna put this side. So this is a good cylinder. This is coming from cylinder number 1, okay? This is the one that we put on cylinder number 1, which is a good cylinder. So I'm gonna put this on the second channel, so channel B, okay? And I will put the one on the faulty cylinder on channel 1, okay? So right there, I got that connected. So we will compare the good cylinder, okay, with the faulty cylinder over there. All right, so we got this connected. Now I'm gonna do this one off camera because there's a lot more things in the way on this side. It's basically the same process. I'm gonna clamp the test lead for the second channel is right over here. So this is what I'm gonna use on cylinder number 4, okay? So I'll get this clamped around the spark plug wire of cylinder number 4, and then I'll bring you guys back up so we can look at the scope patterns. So I will do that and then I'll bring you guys back up. Alright guys, so I got the inductive pickup clamp clamped around the spark plug wire on cylinder number 4. You probably won't be able to see it, but it's somewhere back there, okay? It's the second cylinder on this side. So that's cylinder number 4. And I got both leads connected to my VCMI over here, okay? So everything is connected to the scope, so we are good to go. I'm gonna put it right over here. So let's go to measurements. Okay, let's go to oscilloscope. Okay, so remember, cylinder number 1 is, so A over here is gonna be cylinder 4, and then B will be cylinder 1, which is a good cylinder. So we will compare a non-misfiring cylinder to a misfiring cylinder, okay? So we're gonna set up our probe. Let's go to probe setting. Oh, dang, this thing is annoying. Probe setting. So let's scroll down to secondary ignition probe. Let's click there, okay? So now I'm going to start the engine. So right off the bat, what do you notice? Our pattern is upside down, okay? So we have to go back to the probe setting and select the other probe, this secondary ignition probe inverted, okay? So as you can see, we flipped it back. Okay, so let's turn the trigger on. So let's trigger this. So right off the bat, I can see that this secondary ignition waveform doesn't look good. Okay. So check this out. Look at this. Like there's no spark line over here. So this is an indication of a failing ignition coil, okay? It looks like this coil over here is failing. So I'm going to show you a good one on cylinder number 1. Remember, we clamped our inductive pickup around the spark plug wire on cylinder number 1. So I'm going to turn on the second channel, and this one over here, guys, tells me that this coil is weak. And so now I'm going to turn on the second channel so we can compare this waveform with the waveform we're gonna see on cylinder number 1. So this is faulty, guys. This over here looks like a bad coil pattern. So I'm going to turn on the second channel. So let's unfreeze this. So now what I've noticed with an Autel lab scope, when you have both channels turned on and you are measuring secondary ignition, it's difficult to see both patterns on the screen. So in order to see the pattern on the second trace, we're gonna have to turn off the first trace. Okay, so right there, as you can see, we have a pattern across the screen. So we're gonna increase our voltage scale, and I'm going to trigger this pattern here. So right over here, do you see how nice this one looks? Do you see how we have a spark line over here? I'm gonna rev it. So watch that. Okay, this here is our dwell time. Firing line looks good. We have a spark line over here. Okay, so this is a good looking secondary ignition waveform. So I'm gonna turn this off. Let's look at the one on cylinder number 4 again. So let's trigger this. Yeah, so do you see this? This is a crappy looking waveform. So let's pause this. Okay, so as you can see on this one, let me zoom in a little. This is a little bit hard to do because I'm wearing gloves. Okay, so as you can see right over here, the spark line is not even there. Okay, so this downward line that you see over here next to the firing line, so if you could draw an imaginary line right over here on this spark line, so basically the imaginary line would be right over here in the center. So anything on the right will be inside the cylinder and anything on the left will be outside the cylinder. So ignition coil, wire, spark plug, and so on. Okay, so since we have this over here, this tail here, I believe our issue is our ignition coil. Okay, this over here tells me that the problem we're dealing with is the ignition coil. Okay, so what I want to do is I'm going to replace the ignition coil on cylinder number 4, and we're gonna put plugs and wires on the rest of the cylinders. Okay, so this here looks bad, so we're gonna put a coil on this one. So I have a used coil over here that I can install so that you can see how this waveform will get better. Okay, without even replacing the spark plug and the spark plug wire, I'm gonna install this used coil that I have on cylinder number 4, and you will see this waveform will get better on cylinder number 4. I'm going to replace the plugs and wires. Like I said, I'm also gonna get a new coil on cylinder number 4. But before I do that, I'm gonna install the used one that I have so we can see if our waveform will get better. So now I'm gonna turn off the engine. So let's go under the hood and replace the ignition coil on cylinder number 4. Alright guys, so I've had this old coil laying around here. So I'm gonna install this coil on cylinder number 4, and then we will see if our waveform will get better. Okay, so I'm just gonna try this out, and then I'll get a new coil that we're gonna install here later. Okay, so let's put this on and see what happens. Alright guys, so I got the coil out. Here is the coil that came out of cylinder number 4. So now let's go inside the vehicle and analyze the data. Alright, so back in the car, I'm going to start the engine. Alright, so this pattern over here is still frozen, so we're gonna unfreeze this. Do you see this now? Huh, it just changed, right? It changed because we put a new ignition coil in it. So, I mean, it's the used one that I had laying here around the shop. I think I got it out of a used engine that we got from a junkyard. I was putting an engine on a GMC Savanna, so I kept the coils that came out of a junkyard. So that's how I got that coil. So let's see what we got. As you can see, this looks a lot better now. Okay, so let's turn this off. Let's turn on the second channel. So let's unfreeze this. So let's trigger this over here. So right there, as you can see, this looks good. Let's decrease our time base a little bit. So right there. So the green trace now looks identical to the red trace. So I'm gonna turn this off. Let's turn on the second one. I mean the first one. Let's turn the trigger on. You see that? So the issue was a bad ignition coil. We can just replace the coil and call this a day, but I'm going to just do a tune-up on this vehicle. I'm gonna go ahead and replace the plugs and wires. Let's split the screen and look at the data. So let's go to the scan tool. Let's look at our misfire counters. And this is cylinder 4. Remember, cylinder 4 was misfiring. And here's cylinder 4. As you can see, cylinder 4 is no longer misfiring. And this was misfiring at operating temperature. Let's look at the engine temperature and see. So here's the engine temperature, 190 degrees Fahrenheit. So yeah, pretty much close to operating temperature. So our current misfire counters are showing 00. Okay, so this is good, guys. This is fixed. So now let's look at the check engine light on the dash. Oh wow. It's fixed. So right there, the check engine light went off by itself. I didn't even erase the code. The check engine light went off. This is a good sign. This is good. This tells me that we made the right diagnosis. This is fixed. So right there, guys, you see this? We got a good dwell over here. Nice firing line, nice spark lines. We got some coil oscillations over here. So this is perfect. This is awesome. This is good to go. Okay, so I am going to replace the spark plugs and the spark plug wires. At this point, I mean, I can end this video over here. I'm not going to show you how I'm going to remove and replace the spark plugs on this. Removing and replacing the spark plugs is really straightforward and really easy to do. Okay, so I am also going to get a new coil. I'm just not going to leave this used coil over here on the engine. Okay, so I'll get 8 spark plugs, 8 spark plug wires, and 1 ignition coil that will go on cylinder number 4. Okay, so I'm gonna turn off the engine so we can wrap up this video. Alright guys, so I'm gonna leave it right over here. Let me start it back up just one more time. Let me go back here and actually let me do one thing before we wrap up this video. Let's back out of here. Let's go to trouble codes. Let's go to trouble codes. Alright, so as you can see, our trouble code is still here because I didn't clear it. The trouble code is still there, but the check engine light is off on the dash. So right there, okay? So the check engine light is off. That's good. Okay, so I'm going to turn the ignition off. So let's erase this trouble code. I mean, it's good that the check engine light went off by itself without even erasing the trouble code, because the computer was able to see the correction that we made by changing the ignition coil. Okay, so let's back out. We can go back to our live data. This buzzer is annoying, so I'm gonna start the engine. So right there, this is cylinder number 4. Everything looks good. Our misfire counters over here are not counting anymore. Remember before we had counts on cylinder 4 and 3. All right, so I'm gonna turn off the engine now so we can wrap up this video. Alright guys, so I'm gonna end this video right over here. It was good showing you my new lab scope and using it. So I don't really use it that much, especially the secondary ignition waveform. I don't really do these tests really a lot, so I always enjoy using this whenever I can. Okay, so I'm gonna leave this right over here. I hope you liked the video. If you do like the video, give it a thumbs up. If you don't, give it a thumb down. But if you do, you gotta tell me why so we can make better videos in the future. If this is your first time here, subscribe to the channel. Ring the bell so you can get notified every time I upload a new video. Thanks for watching guys. See you next time.